Hi everyone. Next we're going to talk about our top up extra credit, which is on the software Evolver by the company Palisade. So in terms of what it is actually an add-on to Excel that enables you to find optimal solutions to virtually any type of deterministic problem. That is any problem that doesn't include uncertainty. So Evolver finds the best inputs by optimizing a specific output. So you can use Evolver to find the right mix, ordering or grouping of variables that produces the highest profit, lowest cost, shortest project completion time, lowest risk, etc. You can use Evolver in Excel by first setting up a typical spreadsheet model and then evoking Evolver to find an optimal solution. Why use Evolver? Well, it creates more accurate, meaningful, realistic models of any system and can handle a variety of variables. It's flexible, so not only does it find optimal results for variables, but their position in a lineup, kind of like for a baseball batting lineup. It's easier to use because it's built into Excel and has an intuitive interface. It's cost effective because you don't have to hire consultants to build a custom product, and the many months that might occur from that and the training for staff.
So how does it work? Evolver uses OptQuest and genetic algorithms to search for optimum solutions to a problem. In addition, it determines that a problem is linear. It uses linear programming algorithms. OptQuest uses meta-heuristics, mathematical optimization, and neural network components to guide the search for optimal solutions to decision and planning problems of all types.
So next we're going to talk about the problem. Chapter 10 actually outlines a game, which is the vector game. It's a game very similar to Mastermind, which is a code-breaking game for two players. It's where one opponent gives clues to the other regarding how good their guess is, then using that knowledge from previous guesses to propose new solutions or guesses. The rules to the vector game are quite simple. One opponent secretly writes down a string of 6 digits in which each digit is a decision variable that can take the value of either 0 or 1. Then the other opponent must try to guess that sequence of 6 digits as quickly as possible and within the least amount of attempts. After each guess, the opposing player will tell how many of the digits guessed are correct until the correct sequence of digits is determined. There are two possible methods to solve in this game. One is a purely random method of guessing. The other one is through the use of genetic algorithms.
Okay, so let's actually see Evolver in action. So we go back to our spreadsheet, and the first thing we look at is after we've added Evolver, it goes onto a tab on the menu of Excel, and then it gives us several different things we can click on. The first thing we have is the model definition. So if we click on the model definition, it gives us the ability to connect Evolver to our spreadsheet. Okay, so as we said at the very beginning, we are looking for decimal number 44, which equates to our answer 101100, and in Evolver, we put that as our target value. Okay, and then in the cell, we say where we're going to put Evolver's answer. So Evolver is going to really compare what we put in this case, the number 44, to what it outputs into cell T13. Okay, to do this, we have to put in our input, which is in range R13 through W13. We have to say what kind of answers we're going to let it take. So in this case, we're saying the lowest number it can use is a 0, and the highest number it can use is a 1. And we're telling it can only use integers, so no 0.5s, 0.3s, anything like that. Okay, Evolver also has the ability to put in constraints, but in our model, we don't need constraints. The next thing we do is check Evolver settings. In Evolver settings, we have a screen that allows us to tune Evolver's ability to optimize. We can set things such as the number of trials or how long. We can use a maximum change. So in our case, we're saying stop Evolver when it either gets the correct answer or we see very little change between its trials. Okay, we have several other tabs that allow us to optimize various parts of Evolver. And then we have the ability to run Excel macros. So in this case, we are running an Excel macro at the start of the optimization, and we're running another one after it stores the output. The only thing we're really doing is taking Evolver's answers and putting it into a little better format. Okay. Then when we run Evolver, it's just a matter of, after we've put all the information in, it's a matter of clicking Start. So we're going to run, well, the first thing we do is I want to reset Evolver. So we started at 0, which you can see right here. J2 is 0. And then I'm going to click Start. And now we're looking for the number, the decimal 44, or 101100, which equates to yes, no, yes, yes, no, no. And as you can see it running, it opens up an Evolver progress screen down here at the bottom, and it'll show you the various trials. So far, it took a couple of guesses, but then it found it. After it's finished, then it opens up another window that lets you see what it did. So if we click on Progress, it gives you a graph. Because we have so few trials, these graphs don't show you too much, but if you had hundreds or thousands of trials, then you could see these graphs be meaningful. Okay. The summary, the best trial that it got was trial number 8, which was exactly what we needed. Of course, it was the last trial, because it was going to stop when it got the answer, and the original was all zeros. It gives you a log of every trial, so you can see what it picked for all 8 trials. So the first time, it tried the equivalent of decimal 2, then 63, then 59, and it did that until it got to 44, or our answer. Okay? We could have also controlled some of its stopping options. And as you can see, it did it in 8 trials. Now, as you compare these, you can see that Evolver was pretty efficient. It didn't actually get as lucky as our genetic algorithm did, but that's not always true. Usually Evolver comes up better in most cases. Okay, the only other thing that Evolver does is gives us reporting capability. And under this Reports tab up here, there's 3 reports that you can get, which I have downloaded on tabs in the bottom. So this is the optimization summary, which really shows the summarization of that window that we were looking at, the log of all trials from the window, and the log of the progress steps from the window. And that's how Evolver runs.
The final portion of our presentation is regarding case 10.4, which is a visual simulation model, which is based on improving job shop scheduling decisions through RFID. So we actually asked everybody to prepare this case. So what I'm going to do is just start off with a high-level summary about what the case is. So the case starts off, it's really a manufacturing service provider of complex optical and electrical mechanical components, which is looking to gain efficiencies in its job shop scheduling. One of the major issues that the company is having is there's no system to record or monitor WIP as it moves through the production process, which this causes 2 main issues, which is high backlog, also high cost of overtime. As the current system cannot respond to unexpected changes, such as changes in demand, material shortages, or etc., to quickly revise the scheduling in a cost-effective manner. Some of the solutions that the manufacturer turned to was using a visualization simulation model, which is Simio, which we'll talk a little bit later, to determine if using RFID in the production line is beneficial. In the case, the results show that using the RFID-based scheduling rule generated better performance compared to the traditional scheduling rules which the manufacturer used, which happened to be FIFO, which is first in, first out, and EDD, which is the earliest due date. So what we went through on these next couple of slides are some questions that we developed based on the case. We did upload the questions and answers to Blackboard, so please read those at your earliest convenience. Also, as I'm flipping through some of the slides, you'll see that Simio video here, which is a pretty cool video on how Simio actually works. So I would recommend that you watch this video as well at your own time. And then next is the vector game, which we talked about a little bit earlier. So on Monday, what we're actually going to be doing is playing a pretty neat game called the vector game. We did post the instructions to Blackboard, so please make sure that you read those and have those handy with you for class on Monday, because that will be the first portion of the day we'll be playing this game. We will also have copies of those instructions as well. Thank you.